Cloudfront is honestly one of those few services that are used by almost every single website on the planet. You'd honestly struggle to find a major website that doesn't use Cloudfront to load some of its static files, like images and JavaScript files especially. And for the most part, Cloudfront is pretty safe. It's easy to configure, and honestly there's not a lot of vulnerabilities that can happen here. But as always, when developers start messing around with these AWS services and using them in ways that they're not really supposed to be used, it can lead to some very highly impactful vulnerabilities. And today I'm going to talk about how I found a $25,000 vulnerability in a website that just decided to get a little bit too clever with how they were using Cloudfront, especially how they were using Cloudfront together with S3 buckets, which, as you might have guessed, is one of my favorite attack surfaces to target on a website. As always, I'm going to cover the high level explanation of how Cloudfront interacts with S3, and then I'm also going to show you a live example that you can follow along with and that you can try and solve yourself. And spoiler alert, you probably will be able to solve it because it's not that hard of a vulnerability to find. So what actually is Cloudfront to begin with? Well, Cloudfront is what's known as a content delivery network, which basically means it's a very fancy word for meaning that it's going to get static files or whatever files you want to the end user in a fast and secure way. That's basically what it does. And really the way it works is that it just sits between wherever you have your files, which for Cloudfront is often S3, and it just sits in between the user, and basically it will deliver the files to the user through its own servers. So the CDN today that we're going to talk about is obviously Cloudfront, and this is run by AWS. So this is an Amazon service, which makes sense because a lot of websites use AWS to host their websites. So it's just natural to use Cloudfront as well as the CDN if you're already using AWS for most of the server work on the back end. And the user will be here. Sometimes this is usually on like a Cloudfront domain. So this will be like a random UUID and then .cloudfront.net, I think, or .com. But sometimes this can sit behind a reverse proxy or like, some kind of a CNAME or domain thing that they have set up. So yeah, sometimes you're going to be able to see this directly. You're going to be able to see this Cloudfront endpoint directly, or sometimes you're going to be able to see like static.target.com, which is going to point to Cloudfront anyway. But you can know it's Cloudfront because the server response will say Cloudfront or Amazon S3, depending on how they have it configured. So that's how you'll know it's Cloudfront sitting in between you and the files. And as I mentioned before, the files are often stored on S3, which makes sense because, again, S3 is also an AWS service. And with many of the Cloudfront subscriptions, you get free S3 bucket storage, which is by design because they do want you to use S3 as well and hopefully using those services. So you have to pay Amazon more and they just want to farm monopolies on people. So that's kind of how it works there. So most people use S3, although in theory you can use anything. I think you can use like Azure or whatever storage, Google Cloud or stuff like this, which also works with Cloudfront, but I don't think I've ever seen that in my life. So unless you know a company like that, then most likely it's going to be S3 bucket in the backend, serving static files which are going to be passed to the user. So normally how this works is in particular JavaScript files will be stored here. So if there's like a page, like let's say this is like a React application, it's a single page app as most of them are. The server will give you back this single page app, and then all of the script tags inside the single page app will point to this Cloudfront domain, and the Cloudfront domain will fetch those scripts from the S3 bucket. And the reason we use this S3 bucket instead of just, storing this on our own server is for a number of reasons, but for one of them is that Cloudfront has like defenses and stuff, so they have like security measures against denial of service attacks, and it just makes delivering the content easier that way. There's caching, so especially these JavaScript files can literally be like 400, 500,000 lines long. So making sure that every single user has it cached is quite important. And the caching is pretty hard to get right. For most servers, they don't want to get exposed to attacks with caching, especially things like cache deception and poisoning. So instead of doing that themselves, which is kind of dangerous, all they do is they just outsource it to Cloudfront, which is a lot safer that way. And then there's also fast delivery. So for most servers, they're gonna have servers in a few particular locations. So I live in Europe, so let's say I'm going to access some small website. They're probably not going to have their servers in every single European country, right? They're probably gonna have their servers in like Frankfurt or something, and then all the connections are going to go to Frankfurt. And this is fine for these kind of small applications, but for delivering these huge JavaScript files, you want this to be very low latency, because the faster these JavaScript files get delivered, the faster the website is going to load. And obviously, the slower delivered, the slower the website is going to load. So to give better user experience, we use these CDNs because their servers are often located a lot closer to the user, which reduces the time that needs to occur between the user downloading the file and it getting to their PC, basically. So instead of like in Europe, so instead of just having one server in Frankfurt, AWS would say have servers in like Warsaw, Paris, Madrid, Rome, Stockholm, and like London. We'll say they have a lot more of these servers, which most companies probably can't afford to have that many. But because of economies of scale and whatever, like Amazon can afford to have servers everywhere, and it can also lead to faster delivery. And I didn't write this down, but obviously like file upload things, like holding these files on your own computer, can lead to some dodgy stuff happening. So honestly, it's usually better to use Cloudfront for these kind of things, and it's what it's designed to do. And for the most part, that's it. For most companies, they just have their files stored there and they're all publicly accessible to end user, because the JavaScript files just tend to be publicly accessible. But for a small minority of companies that try and use Cloudfront in these weird ways, you can actually limit access to certain files on Cloudfront. And the way you do that is you configure it inside of AWS, which I'm going to show you that as well. Once we get to the live example, I'll solve the example and I'll actually show you the AWS dashboard and how it looks like for the developers. But basically, you can require Cloudfront to have some kind of key before it accesses some of the files. So by default, if you link it to an S3 bucket, Cloudfront can basically access all the files. And that can lead to vulnerability as well, but I haven't really seen that going wrong at the moment. But yeah, basically it has default access to everything. Let's say you don't want that though. Let's say there's a specific folder like slash secrets dot something, and you want the user to have like a special key to actually go in there. We want to only allow authorized users to access these files, and Cloudfront has a feature like that. And the way that it does that is you upload like your public key to Cloudfront, so your like private key to Cloudfront, and it's going to start signing requests for the user basically. And you'll often see this through the following header. It's going to say key pair ID like this. You're going to see this header here, and that's going to tell you that this file is restricted. So Cloudfront is signing this file, and only certain users are allowed to access them. The key pair ID is basically the key that Cloudfront is using. So you upload your public key to Cloudfront, and your server will sign the requests using the private key. And it looks something like this. Like for the average flow, it looks something like this. So this user sends like this request to the server and says, "Hey, I want to access this file or whatever on the Cloudfront system." And the server checks that the user has access to that. Great. And it signs this key and gives the user the signature to this Cloudfront endpoint using the private key that it has basically stored on the system. The user grabs this key, this like URL, it's a URL by the way, and it fetches the Cloudfront CDN with the URL the server gave it that includes the signature. Cloudfront sees the signature, it has the public key stored, and it verifies the signature against the public key it has stored on the server. It says, yep, that matches, and it lets the request through, and it signs the request itself to S3. So in the S3 bucket, you have to configure that Cloudfront is allowed to access files. And yeah, that's basically how it works. It's pretty similar to the S3 pre-signed URL flow. So the way that the server will basically give the user some kind of signature, and then Cloudfront will verify it later. It's pretty similar to that flow. but it's different in a small number of ways, right? In terms of the signing process, especially. So for AWS, each of the signatures has some properties that it signs that the user cannot change. And one of them is the path, obviously. So the user can't ask for the server for like a path and then change it before it reaches Cloudfront. So you're not allowed to do that. You have to, sorry, before it reaches AWS, you're not allowed to change the path. So the signature only applies to a specific path. Okay. There's also the method. So the server will specify what kind of method it wants the user to use. And this can be like get, so get is the most common one. Put to modify a file, post to create one. So this method is fixed, so the user can't just go in and change it whenever they want to. So that is not allowed. And these are the two default ones. And there's a few other ones that the server can manually configure, like a checksum, so that the user can't actually. But this is only for like adding or modifying files, so that there's like a checksum, so the user can't modify the actual file data, and an ACL whether or not the file is publicly accessible or not. So these are some of the things that are signed with AWS, and you can see it's fairly rigorous, fairly secure because a lot of things are signed. The user can't change much, and the signature is fairly fixed. So as long as the server is signing things correctly, there should be no issue with any kind of security. But now we come over here to Cloudfront. You can see a noticeable lack of pretty much anything here. So you can see that the only thing that Cloudfront actually signs inside of its signature is the path to the file. So the user can't change the path. That's the only thing that's really limited. Now you might ask, what about the method? What about the method? What happens if the user just changes the method? Well, they're actually able to do that. So if you sign a CloudFront request going to the CloudFront domain, the user is fully able to change the method. And I don't think there's even a way to turn this off. So the user can absolutely change the GET request to a PUT request. And I'm going to show you how that works in a live example because it is very interesting. But apart from that, there's basically nothing else that gets signed. So the user can change the method, which is really the main one. But there's no checksum. There's no, private or public. It's whatever you configure in CloudFront basically that matters. And obviously both of these have a expiration as well. So both these have expiration, but that's every single AWS thing has an expiration like that. And this is the main thing that's going to decide if this vulnerability actually applies to CloudFront. So there's these two boxes inside of CloudFront, and this is specifically for configuring the like rule for CloudFront, right? So you choose which requests you want to allow, and this is really why CloudFront doesn't assign the method, is because for like 99% of instances out there, this box is getting ticked, right? So only get and head requests are going to basically matter. And that's because most of them are just fetching JavaScript files from S3 buckets. So there's absolutely no reason to have users be able to modify these files. So that box is just checked, and then there's no security vulnerabilities now because it doesn't matter if the person changes the request to PUT, that request is blocked anyway. So that doesn't really matter. And there's this second box right here, which is allow everything. Literally, like, is allow get, head, post, put, patch, and delete. So every single request method is allowed. And for a small minority of weird services, this is ticked. And when this box gets ticked, any request that you sign, the user can perform any of those actions. So this is something that's different between AWS and CloudFront. Where in AWS, the server has to specifically allow you to modify data. In CloudFront, that's not the case. If you allow data modification, then any user granted a signature can edit the files that apply for that role and the path of that signature. So this is something to be aware of, and it's a big difference between AWS and CloudFront that I don't think a lot of developers get. And now we're going to see how that's going to apply in a live example as well. Okay, so the lab for today, you can see right here, is as always on my bug bounty website, S3 Cloudfront attacks. It's in the description, so you can just go click it there. I highly encourage you to do this lab before you watch me solve it, just to see if you can find this vulnerability yourself. It's not that hard, trust me, it'll take you like 5 minutes. So go do that lab, then come back and watch me solve it. I imagine you solved it now, or failed to solve it, now you need to see me actually do it. Basically, the first step to this kind of bug bounty thing is understanding what we're looking at here. Now this is an app menu, and it says run an existing plugin or submit a new one for review. Now this is some kind of functionality, and a lot of apps have this, a lot of websites have this, especially ones that suffer from feature bloat, which is pretty much most of them nowadays. They have like these extensions or whatever that you can run yourself and make. So basically these are, these things that you can upload and change the app in some way. We're just going to see how this works though. If you're, sorry, actually I probably should have mentioned this before, but if you're running the labs, just before you run them, maybe hit this reset button and just reset it just so that, stuff doesn't break when you're actually trying to run it. So hit that reset button and then hopefully you'll be able to run the labs normally. It's just because we're modifying files on buckets and stuff and it can get a little bit weird. So press that button and then try to run the lab normally. But anyway, we're going to see what happens. So the most exciting button here to press, I think, is this run app button. So I'm going to go into my HTTP proxy, which in this case is Kaido, and I'm going to press this run app button. So I'm going to run it, and something actually did run. Wait, did I actually intercept it? No, do I have my proxy on? Okay, apparently I do not have it on. Okay, my bad. Come back here. Hopefully the proxy is now running. We'll press run app now. You can see the button froze, which is exactly what I want. And then you can see that there's this request being made. Okay, so I'm going to send all these requests to the repeater. And then this one is going to happen after as well. So I'm going to send this one as well. Okay, I don't know what. Okay, send all those to the repeater and we'll just examine them. So the first thing that happens is we get this thing getting sent to the endpoint. So get run url.php and there's some kind of ID there. So we'll send that request and we get our Cloudfront signature. So as I mentioned before, this is most likely using the signature method for Cloudfront. The reason is because you see this key pair ID here and the signature as well. So this is different from the AWS signature, which will not have this key pair ID here, but the Cloudfront signature will have this key pair ID thing here, which is good. So now we know that it's using Cloudflare instead of AWS signatures. So that opens up the door to that attack that I talked about in the high level explanation. Now for a couple of things you could test here, so you could check if this ID parameter is enforced, which it isn't. So yeah, I guess you could try and look for vulnerability there, but it doesn't seem like there'll be much because, okay, that's verified. And we're kind of stuck in this code directory and plugins. I don't think we'll be able to traverse this or anything like that. So this probably is a dead end, but could potentially allow us to fetch apps for IDs that we don't own. So kind of an IDOR situation there. But since there's only 3 and they're all public, then we probably won't be able to get anything. But could be an attack vector. So we'll move on from that. And then, there's probably some browser side logic that, reads this request and then processes it and then fetches it on the client side. So we got this. I think are these the same? Script empty. I think these may be the same. Okay, I think these are probably the same. So once we fetch this, you'll see it's going to give us the source code. So this is going to give us the source code for the app. So, well, I'm kind of building a mental model here, but when I'm hacking, I always try and build a mental model of what the application is doing, how it works, why certain decisions were made. And the way I think this works is that we press this run button and then the server gets this ID from some kind of database. It compiles that client side into that request. It fetches the source code, which is stored on that on that Cloudfront domain, and then the client pulls that source code and runs it locally with like eval or potentially loading it into a script.source. So that's kind of how I built this mental model of how this works. And now I'm going to have to start asking some questions like, okay, well, how does this code end up on this Cloudfront URL or on this S3 bucket? So what does the upload for this look like, especially? How does one upload something to this S3 bucket? And, you know, we can probably test that pretty quickly now. So we can check this create new app feature. So I'm going to go there, and we're hopefully going to get some of our questions answered from this. So once again, I'm going to open up my proxy here. I'm going to press create a new app. I don't think anything triggered, so at least we know that it's not, so it's not creating an app here. It's spawning this model, which is all client side for now. So we'll just put in like, I don't know, testy123, the classic, and then I'll put in some source code. Okay, I just put in one of the source code files for these plugins that I have on my computer. So I just submit that. Sorry, first of all, make sure the proxy is here. Just press submit on that. Uploading. So once again, it's getting this one of these PHP endpoints. So get upload URL. So we'll send that in, and then it's doing an options request. This is a pre-flight course check. So we don't need to save that because it's just a course check. And then it's putting something. Okay, cool. So we'll send all those requests and we'll have a look at them in the browser. So this first one, as pretty common, is to fetch some kind of upload URL. So the server, presumably, once again building this mental model, has some kind of credentials on the back end, like AWS credentials or that, Cloudfront private key. So probably this URL is going to return some kind of pre-signed URL, and it's going to allow us to upload the code to that S3 bucket place. Now we send this request, and you can see that we have a upload URL as we thought. So this probably gets ingested by the browser, gets processed, probably like escaping this JSON and stuff like that, and then it gets fetched as a path. And we have this here. So this is going to get used by the browser, which is presumably the next request, which is right here. And then we have this put URL right here. And you can see that we're still using the Cloudfront, signature method because key pair ID is still there. So this is not using AWS pre-signed URLs, which might mean that the S3 bucket is private. So they're using exclusively Cloudfront for this. Or that they just don't want to use it. They just prefer using this thing. Maybe they've already built logic for this in the backend and they just want to reuse it themselves. So something like that could also happen. And you can see the code that I've uploaded, which gets put here. So now we know that pull requests are enabled on this Cloudfront instance. And as you remember before, the thing that a lot of developers forget is that when you allow any pull request on this Cloudfront instance, any GET request can be changed into a pull request. So if we go back to our HTTP proxy, right here, we intercept it again, and we try and run one of these apps, we'll go back here, and we'll send this back to the repeater. If we go to this, you'll see we are able to, sorry, that's not the one that I wanted, sorry, it's the next one. So if we go here, and we get this Cloudfront URL instead, we get it. Now, what we can test for is whether or not we can just change this from get to put. And you can see we came back with this 200 OK. That means that it worked. Now let's try something, adding in like test or something here, putting it, sending it again, and then getting it like this. And you can see if we were able to modify the data, and we actually were able to modify it. And as you can see, you saw yourself, there's nothing stopping someone from changing those request methods in Cloudfront. It does not work the same way as AWS. So that's what allows us to do it. Now, how do we craft an exploit? So first of all, we need to get one of those scripts here, and then we'll upload a malicious script as one of the users. We'll pop it in here. We'll set the content type to application/JSON, and we'll just put a bit of content length in here as well. Sorry, not JSON, sorry. Text/JavaScript, like so. And then we'll say content type 0, so Kaido will autofill that for us. And we'll just edit this, so instead of doing this, it's just going to alert, one. So that's what we'll just change it to. We'll send this pull request. Once we send this get request, you can see that it has been saved for every user. So once we go here and we once again click run app, turning off the proxy, you can see we have printed alert 1. And why is the impact of this so large? Well, the reason is because any user who installs this app would now get our new source code. So we've overwritten the source code for this app. So not only can we cause with this denial of service, but we can basically have cross-site scripting on every user on the platform now, which is huge because we're able to use their credentials and stuff to get anything. We can build these automatic exploits for them, and not only that, it's actually zero click in a lot of applications, because once you install this app, it's going to run every single time you go into the application, even if you don't intentionally run it, because a lot of them run passively in the background. And we'll say there's like an install button, and the app will auto run it every single time you go into the application. If you're able to replace the source code, well, you can basically get zero click account takeover on a lot of accounts, which is why this ended up being a critical vulnerability in the application I was hacking. So once you do that, you can press reset again to make it run normally, and then we can run the application again just as is. So that's why this bug was so major. And you can see that the root cause of it was just this misunderstanding about how Cloudfront works and how it compares to AWS. And really, I think Cloudfront should never be used to modify files this way. Unless you want this file to be modifiable by every single user, I don't think Cloudfront is a good option for you, because then nobody can read this file. So you would only be able to basically do this stack in this way if the only user able to read the file was the user that was able to modify it in the beginning. But this is not common on most applications, so I don't think Cloudfront's a good option. What you should do instead is simply have the Cloudfront URL serve the static data, so the code and stuff. That's fine, you can run that through Cloudfront, but all modifications should be done through the AWS pre-signed URL instead. So the technique that I showed you in the S3 bucket. And then obviously disabling pull requests, post requests, delete requests entirely from Cloudfront as well. Okay, I said I would show you how these developers actually configure this Cloudfront stuff in the backend. So you can come here and you can see, this is S3, okay. Here you can see my AWS console. Hopefully I don't end up leaking anything or my credentials or something. But anyway, you can see here, this is the Cloudfront instance that we're looking at. So you can just come here and verify that it's actually the same one, KRC and KRC. You can see that this is the Cloudfront instance that I own. So I created this for this bug bounty lab, and it's called Jacob JN Bug Bounty as normal. And I'll just show you in here the place that actually has this functionality. And it's going to be under behaviors, specifically here. So /plugins *. Now what this allows you to do is basically create behaviors for each of these CloudFront path patterns. So if we go into plugins, I'll just go into edit here. You can see that we can set the exact behavior that I actually talked about. Now normally most of this doesn't really matter, it's like HTTPS only, but this is the stuff that actually does matter. You can see allowed HTTP methods. You can see get head options, and then basically everything else. So just no really granular control over basically allowing a user to, just do a delete request or something. So you have to allow every single one of these. And then you can see here, so viewer access restricted. So once this is set to yes, then what this basically means is that you can't just go into the CloudFront instance and just view this file. So what that means is that I can't just copy this path into here and go to this endpoint and try and view it. So what it will tell me is it'll be like, I'll actually show you this. If I got rid of the signature here and I just try to get this file, you'll see I'll get a forbidden error, and it'll say missing key pair ID, just because I've turned on that functionality in CloudFront. That of course, if I set this to no, then that means anyone will be able to edit it without any signature. So that's the key difference here. And then we add a trusted key, and this is just the public key that I use to authenticate it. And then there's also one on the server, that's the private key, which actually signs the request. And there's a few things like caching. I've disabled caching on this, specifically just because you can actually see it a lot better. On the target that I was hacking, caching was enabled. So when I accidentally overwrote the file, the cache actually, prevented the changes from being propagated. So I was able to report the vulnerability and actually restore the file to its previous state without any sort of changes being implemented on the server, which is pretty nice because I didn't want to, cause denial of service by accident, which is good. So normally caching will be enabled because that's the whole point of Cloudfront, is that caching is enabled, and then just cores or whatever. So these are the main options, and I think this is actually a great vulnerability to look for because of a few reasons. Let me just save changes and go back. Yeah, here. So you can see with these behaviors, different directories can have different patterns, and some of them could just be get read, and some of them could be modified, which is what we're kind of looking for. What makes this good is that it's actually hard for scanners and automated scanners to find this because of the way that these directories are specified. The automated scanner wouldn't know what directory we're looking at, right? So the automated scanner wouldn't know that this path has a different behavior to this other one. The automated scanner would most likely just go here and check if like put is enabled or whatever, and if it is, then I'll be like reporting or whatever. Most likely for this default endpoint, it's not going to be enabled, right? That's just the like kind of stupid configuration, right? But for some other endpoints, it might be. But that kind of requires application specific knowledge at that point, because you have to know that this app has some kind of functionality like this, and you have to find the actual request that signs this path for you, and then you have to test if this pull request works. Because like even if you knew that this behavior existed, if you didn't have the endpoint that signed it, you wouldn't be able to test if put is enabled anyway. So I think this vulnerability is actually pretty decent. I think it's kind of something that you could even look for in the targets that you're hacking at, just because scanners are going to struggle to pick this up because it requires that kind of application specific knowledge, and with different paths being configured differently, it's really hard to build a scanner for this that works for every single Cloudfront integration out there, because each of them are going to have different behaviors configured. So that's why I think this vulnerability could actually be pretty useful to you as well. Now on the S3 side of the story, we're going to look at permissions, and this is more or less what it looks like. So we have to have this bucket policy enabled, right? So this bucket policy, basically what this is going to do is it's going to allow Cloudfront specifically, so this source ARN thing, which is Cloudfront, to be able to get objects and put objects. Now, I think by default, S3 will give you this without the put object. It will just give you the get object. So that's kind of the safe way to do it. But I think if you set put to true in this plugins page, then I think this might also do it automatically. So I'm not too sure of that, but I had to type this in myself. So that's something that you might note. And these two things have to be on. So this pull request has to be on for this to work. And then if you go in here to this edit page, this also has to be on. So these two boxes have to basically be filled. This put object has to be here, and this box has to be ticked for this to work. And if that is true, then this vulnerability is there. And that's basically how that is. And I think that's pretty much it. Yeah, this cores or whatever, this doesn't really matter though. So that's the main thing. So the developers have to go into this console. They have to set up a behavior here for some path or default path or whatever, and then enable this option here, allowing all the HTTP methods. And then they have to also allow Cloudfront to create objects in the bucket. So these are the two behaviors that are going to allow this vulnerability to exist. And yeah, I hope you enjoyed this video covering this S3 bucket with Cloudfront interaction vulnerability. I think this really shows just how achievable getting a critical vulnerability is. It really didn't require that much skill to find this, to be honest. It was only just a little bit of luck on the side that it was configured with. Obviously, it does require understanding the target that you're attacking. It does require going a little bit deeper and actually looking at the functionality, looking at, you know, how things were implemented and the potential security vulnerabilities that might be there. But honestly, at the end of the day, it is just a bit of time consistency and a tiny bit of luck on the side, which I think is a little bit manufactured as well. You can definitely influence the luck that you have just by the hacking techniques that you use as well. And I hope that, you know, one day you're going to also have the stroke of luck, and then you're also going to be able to find that critical vulnerability if you haven't found one already, of course. Well, if you're, you know, just starting out, then I think it's very achievable to find these kind of vulnerabilities. And honestly, if you just, you know, spend time on the target, learn it, understand how it works, and, you know, just kind of critically think about some of the design decisions that are made by the developers, then I'm sure these vulnerabilities will start coming your way as well. And yeah, my goal for this year was to get $20,000, which has already been achieved by April. So I feel pretty happy about that, but we obviously need a new goal. So I think by the end of this year, I'm going to aim for $100,000. So we'll see if we can achieve that. And I also wish you luck in your goals, whatever hacking goals that you have set for yourself. And yeah, let's see if we can get it this year, boys. So anyway, that's it for me. Thanks for watching and happy hunting.